Howdy, this is Coach Loco Young. Today I'm going to demonstrate how to use the notebook script to perform the model training and model deployment. Here is the GitHub page, contains all the file I've been working in this semester, and we will talk about each one in a minute. Firstly, I want to show you how to go through the step-by-step instruction to install the necessary libraries and create an environment in order to run the script on Jupyter Notebook. First, installation of Anaconda is highly recommended. It comes with all the essential packages, although it might be overkill for this application, but it provides a very easy configuration to create and manipulate the virtual environment. And secondly, we want to download this GitHub repository to our local machine or to Google Colabs in order to use this modified version of Microsoft Computer Vision Receipt Library. Although we can clone the repository, but it requires my administrative login in order to access the file. The alternative way is to download the repository from the drop-down menu here and download the zip. And once you download the zip file, extract the file to some directory, and let's browse what's inside the directory. So here we have the root directory for all the model saving, loading the data, and the model training notebooks, and the model deployment notebooks. Of course, the most important is this modified utility computer vision library. Now we want to redirect to this root directory. And we will see all the files in the terminal. And next, let's run this line to create the virtual environment with all the essential packages. This process might take a minute or two. I will fast forward to the finish of installation. Okay, now we finished the installation. Let's check the environment. All right, we see the CNCE 636 ZV virtual environment is now created. Next, let's activate the virtual environment. And next step, we want to create an IPython kernel. So to show this virtual environment in Jupyter Notebook. And now launch the Jupyter Notebook. All right, here we are seeing the notebooks for training the model and model deployment. First of all, I'm gonna use one of the example to demonstrate how to train the model. All right, this model training script demonstrated how to train the deep learning model for target action recognition. And my selected action is sharpening knives. First, let's import all the libraries that's gonna be used in the next few cells. And here it shows like which version of Python you're using and the version of PyTorch, Torch Visions, and if you are using GPU on local machine. So now we are directing the data path to the data folder. It's shown right here. And next, we want to prepare the training and validation dataset. In this repository, I prepare some example datasets. It's downloaded from Kinetic 400 or Kinetic 700. So we are redirecting the data path to Kinetic 700 2020, and we are seeing two classes are created, the sharpening knife and the force class. For demonstration purpose, I'm gonna limit the video clips to about 60. But for the actual model training, I used about 300 clips for each classes. Then we want to decide if we want to use 32 frames or 8 frames detections. 32 frames detection model provides higher accuracy. But here's some catch, and I would explain why it's not good to use 32 frames for this assignment. So let's go for 8 frames model for now. The actual model is trained for 20 epochs. But for the time being, I'm going to demonstrate it only 5 epochs. Now we have to decide the batch size for the training, and the number here, it really depends on how powerful your machine is. And right now I'm gonna set it to 10. And also the learning rate is gonna affect by your GPU memory as well. And I found this number is working for my GPU. Now let's check the list of classes that we have. We see a force class and sharpening knife as my target action. And now we use the utility CV function to split the training and test dataset. The split ratio is 75% and 25%. Now let's see how many clips contained in the training dataset and how many for the test dataset. So we have a total about 120 clips, and it roughly split the training dataset to 90 clips and 29 clips for testing dataset. Now let's inspect some of the test dataset. Excuse me, the training dataset. And here we can see a couple of frames of the clips in the training dataset, showing it's sharpening a knife for indexing 1. And for force class, the index is 0. Now I want to load the initial weight from pre-trained model from R2 plus 1D training on Instagram 65 million videos. As I mentioned before, we have an 8 frame model or 32 frame model. And we have two options. The initial weight is trained based on the Instagram 65 million video clips or Kinetic 400. And here I'm demonstrating using the model and the pre-trained weight based on the Instagram 65 million. Next step, let's build the model and fit the model. So this training process might take a while. I will fast forward to the finish of the training. Now we can see the test performance during the model training. The blue line represents the test accuracy, and the red line represents the loss. In this graph, the performance is not good. It's because we only use so few of epochs during the training. The actual model is trained on 20 epochs, and the test accuracy is above 90%. Now let's evaluate the model with the validation dataset. Now we can see the validation accuracy is at about 60%. Again, the actual model has about 90% test accuracy. Next step, let's try to feed some unknown video to the model and see how it detects. Here you will see the total frames of the videos and the detected actions with the confidence level. And this example shows the video clips is detected as sharpening the knife with confidence level at 64%. Once you are satisfied with the model training, next we need to save the model. This is the end of training model demonstration. Next, we are going to talk about the model deployment.